Yes, hello guys. Thank you for been watching all these videos that I've been uploading. So now I just want to wind up for ellipses, or just to give you a brief summary on the ellipses, and then all other questions that they ask under ellipses. So here we go. The question says we are given an ellipse of the equation 25x squared plus 9y squared plus 200x plus 175 equals 0. And then in number A they are saying write the formula in standard form. Okay, find the center of an ellipse, find the foci of an ellipse, find the covertices, find the vertices, find the minor and find the major also, and then find E, which is eccentricity. Okay, so today I'm going to show you all what you need, or how you can tackle all such questions when it comes to ellipses. And then from here, I know all of you guys some of you are going to write tests, some of you are going to write exams. You are going to be sorted. So let's start with number A. Say write the formula in standard form. Okay, writing the formula in standard form. So we can see here a formula of an ellipse was supposed to have something under here, and then also something under the y axis, and then this should be equals to 1. So we are kind of trying to figure out ways of mingling or just play around with the equation so that it becomes a standard equation of an ellipse. So when we are given such equations, we use the method called completing of squares. But if you guys are not familiar with completing squares, you can just drop a comment or just ask, so that I can also present on how you can complete squares. So first of all, before we touch anything, I just want to rewrite this equation so that it makes sense, so that it looks to us more familiar. So it will be 25x squared, and then just trying to also rearrange some of the things which looks messed up, and then sometimes you might not even be able to recognize that this one is an ellipse formula. Okay, so I'm just trying to group by like terms, x and x, and then y also with y if there's any, but if there's nothing, so we leave it like that. So now we have 25x squared plus 200x, and then also I can just write y here, which is 9y squared also, and then we can say this one now is equals to 175. Okay, as we can see now, the equation is coming, and then it's looking quite proper now and easier to deal with. So before we start with completing square, I just want us to find out if we can kind of divide this so that it becomes again more simpler and simpler to deal with. So I can say I can divide the whole equation by 25, so by getting x squared, and then this one becomes 8x, and then this one becomes 9 over 25, and then this one becomes 7. Okay, so the first step is giving us x squared the first step is giving us x squared. Let's try this one in the maths format. So it's giving us x squared because we are saying we just divided by 25, so 25 by 25 you get x squared here, and then plus 9 over 25, because if we divide 9 by 25, then let's just leave it as 9 over 25, but 9y squared, so it's 9y squared over 25. No, supposed to write this one here because we just rewrote this one this way. So this one becomes 8, so that one becomes 8x, and then this one we just did it, and then this one now equals to this one, also becomes 7, so it becomes 7. So, and then by completing square we just divide this by 2. So we just divide by the number by 2, and then we add also the answer that we'll get here, we subtract it on, we square it and then we subtract it on. So in this case this will be given by so now it follows that x, so let's just put this one in bracket. But if you guys are not familiar with how to complete squares, or how to do completing of squares, then you can just drop a comment or a question or a request, so that I can also present on you to you how to do that thing of completing squares. So this, now we are having x, so just copy x here and then put plus, and then this one 8 divided by 2, so it becomes 4, and then we just square this one, like completing squares, and then we add this 4 squared here, so it's kind of like saying we're adding 4 squared, 4 squared, 4 squared, and then now plus this one. So this one we're also supposed to add this one squared, but since there's only this coefficient here, we only have y alone, so we don't have any other y, so we just say, we assume that y is like plus 0y. So in that way we just write this one as it is. So this one becomes plus 9 over 25. Let me just write it in proper way. So it's 9y squared over 25 equals to 7. So this one goes to 16, and then this one was supposed to be minus 4, so this one goes to 16, so that will be equals to x plus 4, then everything squared, everything squared, and then minus 16. Yes, minus 16, so it's 4 squared is 16, and then plus 9 just write this one, 9y squared over 25 is equals to 7. So we now want to write this one so that this 7 equals 1, and then also we want to correct like terms so that this one, the minus 16, comes to 7. And then this was supposed to be, sorry, I'm just realizing this one now. So this was supposed to be minus 175. This is minus. So this also becomes minus 7, because we are saying we take this one from this side to this side. So there we go. If we take this 16 to this side, then you get minus yes, if we take this one to this side, then you get minus 7. So this becomes, let's just do that one and see without wasting any time. So this becomes x plus 4 everything squared, and then now plus this one, 9y over now 9y squared over 25, 9y squared then over 25. It's equal to, if we take this one to this side, then it gets equals to 9. So this one becomes 9 here. Okay, so again we can just simplify this one right away. Just simplify this one, so we can say this is the same thing as this is the same thing as so we want to make this one equals 1, because don't forget, in the equation of an ellipse, so we have everything, the x and the y's equals 1. Okay, so we also want to make this 9 1, so we divide the whole thing by 9, so we get x minus 4, then everything squared. Let's just do this, and then we just divide it by 9. So we are dividing by 9, we are dividing throughout by 9, and then if we divide this 9y squared over 25, then 9 cancels the other 9, then it becomes y over 25. So we get y squared, you get plus y squared over, just write this one nicely, over 25, sorry, supposed to be y, this y squared over 25 is equals to 1. Yep. And now our equation is in standard form. So we are done with the first part. Let's go further and find out what the other question is. So now it's saying find the center of an ellipse. Okay, so this is simple, because if we go to this equation, we can already see that this is y minus 0, so the center is at 0, and then this is 4, so it becomes minus 4. So if we do this, we find that B is given by so B, the center is at, let's write center here, is at 4, because this 4 belongs to the x part, and then this is like minus nothing, so it's like minus 0, it belongs to the y part, so it's minus 4, and then so you know when you are solving this one, so 4 becomes minus. Just take it that way, that this one becomes minus when you solve it that way, and then for now you can just ignore the square there, and then know that when you are solving x plus 4 is equals to 0, then this one becomes minus 4. So that's the translation, and then that thing comes from the translation. As I've stated earlier, if you didn't watch my other video, then just go back there and then check out my other videos that I presented earlier. And then so the other one is 0, so those are the coordinates of the center. Let's move on. Now we go to, let's just find out which one else we can find without struggle. Or okay, so also let's just because we know the vertices and the co-vertices are found by B, because we know the co-vertices is the co-vertices is at A, no, it's at B, and then the vertices is at A, so it's plus and minus A. Or we can say it's the other side of the, we can also say the co-vertices are either the other side of an ellipse, and then the other side also of an ellipse. So this is what we are saying. Let's find out if we can figure out that using the equation that we get here. So let's first find out what is B. We also know that the B1 is the shorter part, and then the C is the longer part. I mean the A is the longer side of an ellipse. So from here we can just say A, because A is already from here. We know this one is A divided by A, and B cubed, I mean squared. So we know this number is squared and also this number is squared, but we don't know which one is which. But we can figure it out because we know that the smallest number is the b1, is the one which is representing b, and then the bigger number is our a. Okay, so from here we can see that this is the smallest number, so this becomes our b squared. So our b squared is equals to 9, but we know that the square root of 9 is equals to 3, so our b is 3, and then a is now given by the 25, because we are saying 25 is the bigger number. So that is it. 25, the square root of 25 is 5, so our a is 5, and then our b is 3. So then from there we can now start sketching, just to make sure that, but before we do that, I just also want to remind you that by definition, c squared, as we know, c squared is equals to the bigger number, which is a squared minus b squared. So we should always keep in mind that this is our one of our formulas that we should know. Okay, so now let's go to the graph and try to plot what we have. So we are having the center, and then we can just plot out what we have on the graph. If we come on the graph, we know that our center is located at 4. That's our center. So it's located at 0 and minus 4. So we have calculated here, you can remember. So this is the minus 4, and then this is the 0, because it's y squared minus 0. So it's kind of y minus 0, and then everything squared. Okay, so we now know that there is a line that moves 3 units, but that the 3 units are dividing x. So we are moving into x 3 units. We are saying b is 3 units, and then we get 3 from 9, of which 9 is dividing x. So we move 3 units from here. So it's 1, 2, 3. So you can say this is one of our points, and then again 1, 2, 3. So this is another point that we have, and then we now come to the other points that we want to find out. We said, so a is 5 units from the center, so count 5 units from the center, but don't forget how we get a. We found it from, we said it's our biggest number, and then it's the square root of that biggest number. So, and our biggest number is 25, and the square root of 25 is 5. So, and then this one is dividing y. So we move now in along the y-axis 5 units. So it's 1, 2, 3, 4, 5, and they are saying this is our major. We know, so 1, 2, 3, 4, 5, because we are saying the major is the longest. Vertices or the longest line in the ellipse. So now we know that this is our major line and then this is our minor. So this way we can just connect. Let's just connect the lines. So sorry, so to undo this, okay, so we want to connect the lines. So let's see this. Okay, that's beautiful. And it was supposed to be 5 units. So 1, 2, 3, 4, 5. So that's it. This is the major, this is the minor, and then now we are just left with finding the eccentricity and also finding the focal point. But we know that the focal point always lies in the major in the major line. And then we know also that let me just give you that formula also, so that everything will be easier for you. And then you guys, when are going to write your exams, I want all of you to pass this. I mean, there's no reason for someone to fail these types of questions. Okay, so let's just put the answers as they've requested. They are saying find the co-vertices. So the co-vertices here are at co-vertices, or the shorter vertices are at -7 and 4. So this how I like this. So it's minus no so it's -7 and 0 in the y-axis, and then -1 and 0 in the y-axis. So this is why I love this. It's very simple and straightforward. So let's just give them their answer, because we don't want to waste any time on this. So the co-vertices, let's say it's covert, it's at a -7 in the y-axis, I mean in the x-axis, and 0 in the x-axis, and it's also at it's -1, as we've seen from there, and then again 0. So this one kind of repeat itself. It's the beauty of mathematics. Yes, so that's it. See that? And then we can also give the vertices themselves. So say this is D, then let's give the vertices. So the vertices, as we've seen from here, are located at, because we are saying the vertices are the longer is at the end point of a major, or the longer line in the ellipse. So this is 5 and -4, and then again -5 and -4. So that's beautiful. It's pretty good. I love that. So we are saying the vertices are located at say it is minus 4 in the x-axis. And then we are saying minus 4 because so this line, whatever anything in this line cuts the x-axis at minus 4. So if everything is being affected by that coordinate. So again, we can just say the vertices there, minus 4 in the x-axis, minus 4, and then 5, and also minus 4 and minus 5. So that is it. Let's go on to find, I think we are just left with one question now, of which is so we are actually left with two questions that we didn't answer: the eccentricity and then the foci, which is in C. I think even the way we have ordered our things, wrote our things, it's not really in order, but it's fine. We can change this one to G and then this one to E, so that we have C here, just to make sure that everything is in order. But then now this is the easiest part that you guys should you guys shouldn't fail. I don't want any of you to fail this kind of questions, because they are very simple and straightforward, and I'm giving you everything. I'm doing all the best to give you all the answers, all the solutions, and all the possible tactics and tricks to solve these questions. Okay, but if you have any questions, so don't hesitate to ask me. I'll help you. It's for free, and then I just love that. I just love doing that. I want to make sure that we give all the lecturers a headache when it comes to mathematical equations. Okay, so that's the end of the story. Let's just continue with what we're supposed to do. So now we are finding the foci. We are saying the foci is a distance from the center, the focal point, and then at that distance there exists a right angled triangle. Whatever distance you go extend to kind of the curve of an ellipse, and then that distance never changes, no matter how far you go. So that distance remain the same. So not to waste time, we use because that's formed by a triangle. So we use this formula here. We say c squared, as I've already illustrated earlier. So this is the thing, or this is the distance. So the distance c squared is given by a squared minus b squared. So we are saying c squared is the distance from the center of an ellipse to the focal point. So that's simple and straightforward. It's interesting if you look at these things with understanding, so you guys don't have to panic, you don't have to struggle when you are doing these things. Okay, so let's go on. So we don't know what is C, but we know what is our A, and we know what is B. So our B is 9, because we are saying it's the shortest one, or which is 3 squared, as we can see from here. So this is B, and then this is A. So it's 9 squared minus 25. Minus 25. Oh, sorry. It's not 9 squared, but it's 25. So it's 25 minus 9, which is equals to, so this is equals to that, and then that gives us 16 units. So this gives us 16, and then we know the square root of let's just write it properly so that I don't make, so that no one get lost. So we are saying now c squared is equals to 16. Is equals to 16. But if you want to remove this square here, so we just square both sides. Square that one, and then again let's square this one. I mean, find the square root of that one, and then so this one becomes 4. So we get that our c is now given by, so our c is equals to 4 units. So we are saying the foci is away from the center with 4 units. So and then